Hello geometry students, I hope that everybody is doing well. We are in section 8-3 today, and it's a pretty big section, so we're going to spend 2 days on it. So we're in 8-3. First of all, we need to cover a little bit of vocabulary. This section is all about trigonometry, and so we're going to have a lot of new words and just kind of new ways to think about things. So what is a trigonometric ratio, or what are the trigonometry ratios? So it is essentially when you compare two sides of a right triangle. So remember, in this whole chapter, we're always using right triangles, and now we're going to be comparing two sides. Now I'm going to show you or give you some definitions. Just stick with me because you'll know what these mean in just a second. Sine means opposite over hypotenuse. Cosine means adjacent over hypotenuse. And tangent means opposite over adjacent. Now, what on earth does that mean? Let's draw an image and I'll show you how that works. So let's say that we have a right triangle like this. Down here is my 90-degree angle, and I'm going to have angle A right here. And let's call the other sides of the triangle, or the sides of the triangle, X, Y, and Z. Now, when I have comparisons considering sine, cosine, and tangent, I might ask myself, what is the sine of angle A? So I'm asking myself, what is the relationship or the ratio of the opposite side and the hypotenuse in relation to angle A? So let's do that. So I have the sine of A is equal to, so here's my angle, and I want to know the sine of this angle. So I'm going to go back up here to my definition, and it says opposite over hypotenuse. Well, the opposite side from angle A is on the opposite end of the triangle, so it's way over here, X. So I'm going to put X over, and then the hypotenuse of the triangle is the longest side, Z. So sine of A is comparing the opposite side of the triangle from A to the hypotenuse. Let's do that for cosine. Cosine is adjacent over hypotenuse. So if I want to know the cosine of angle A, here's my angle, and I want to know what side is adjacent to angle A or near angle A. That's going to be the side labeled with Y. Over the hypotenuse, well, the hypotenuse is still Z. Finally, I want to find the tangent of A. So the tangent is going to be opposite over adjacent. So the opposite side from A is X, and the adjacent side from angle A is Y. So I have X over Y. Now here's what I want you to know about these trigonometric ratios. It is relative to your angle. So just because the sine of A is X over Z does not mean if I were to put, I don't know, angle B up here, the sine of A is not the same thing as sine of B, because the opposite side from B is now Y, while the hypotenuse is still Z. Let's put this into practice in this next example. Oh, sorry, I accidentally forgot to mention. There is a mnemonic device to kind of help. It's called SOHCAHTOA. And it's spelled like this, SOHCAHTOA. And each of these letters is going to represent the beginning of one of these words. So sine, S, is opposite over hypotenuse. Cosine, C, is adjacent over hypotenuse. tangent T is opposite over adjacent, just like my definition. So this is what I use a lot to kind of help me keep my trig function straight, because the big part is knowing their definitions. Alrighty, so now it says, write each trigonometric ratio first as a fraction in simplest form, then as a decimal to the nearest 10 thousandths, which is 4 decimals. So I want to know the sine of J. Sine is opposite over hypotenuse. So up here is the J. The opposite side from J is 60, while the hypotenuse is 61. So I've got 60 over 61. Then when I put that into my calculator to get a decimal, I'm going to get 0.9836. Now I want to know the cosine of J. That's adjacent over hypotenuse. So here's my angle J. The adjacent side is side 11, and the hypotenuse is still 61. So I have 11 over 61. When I put that into my calculator to get a decimal, I get 0.1803. And finally, I want the tangent of J, so that's going to be opposite over adjacent, which is 60 over 11. And when I put that into my calculator, I'm going to get 5.4545. Alrighty. Let's move on to the next one. It says use your calculator to find each trig ratio, round to the nearest 10,000th. So the way you're going to do that, I'm going to see if I can get this in here. Here we go. First of all, I don't know if you can see, but right here it says DEG. That represents degree. You want to make sure that whatever calculator you're using, because I know a lot of people have different types, you want to make sure that it's set into degree mode, because in different studies of math, there's different ways to measure angles, but for this class, we're always going to use degrees. And how I'm going to calculate the sine of 52, I'm going to click this button right here that says SIN. I click that, and then I enter 52, close my parenthesis, click equals, and then I'm going to round to 4 decimals, so that's going to be 0.7880. So I'll go ahead and write that out for us. Let's do that again for the next one, which is cosine of 19 degrees. I'm going to clear that out. I'm going to click the cosine key, which is COS, and then I'm going to enter 19, because that's the degree that I'm solving for. Click equals, and I get 0.9455. And finally, let's find the tangent of 65 degrees. So this time I'm clicking TAN, and then I input 65, and I'm going to get 2.1445. We'll be learning some more things to do in the calculator later on, but this is just kind of the basics to get us started with learning how to do that. We can also use trig functions, though, to solve for missing sides. So it says, find the missing side lengths of the right triangles using trigonometric ratios. So notice I don't have enough information to use the Pythagorean theorem, and these are not special right triangles. So I need a new way to solve for missing side lengths. That's why we have trigonometric ratios. And I'm going to tell you right now, use regular, I say regular because I don't mean inverse, use regular trig ratios to solve for side lengths. We are not solving for angles right now, we are solving for side lengths. So I want to really make that clear for you guys. So what we do when we have this, I'm going to write my reference of SOHCAHTOA, And I'm going to look at the triangle and consider, what do I know about this triangle? Well, I know this angle right here is 23 degrees. And if I need to call it like a letter to help me make a little bit better sense of it, then I can call it angle A. And then I ask myself, what sides do I know in relation to angle A? Well, 2,500 is the opposite side from angle A, so I know that this is the opposite one. And then X is the hypotenuse. So compared to this angle down here, which is the angle that I know something about, I also know the opposite side from it and the hypotenuse to it. I'm then going to come up here and look at my trig functions and ask myself, what side has both, or what sign or function has the opposite side and the hypotenuse both in them? Well, it can't be cosine because that has an adjacent in it, and it can't be tangent because that has an adjacent in it. So it has to be sine. So I now know I'm going to use my sine function. And I'll write it over here again. Sine is equal to opposite over hypotenuse. So just like on this previous side when I said, oh, the sine of A is equal to opposite over a hypotenuse, I'm going to do the same thing here, but instead of writing A, I'm going to put in my degree value. So I'm going to say the sine of 23 degrees is equal to, now the opposite side from 23 is 2,500 over X. Now I'm ready to start solving. I want to isolate X, so the way I'm going to do that is by first getting it out of the denominator. But I just thought of something, and I don't know, this might be easier, I'm not sure. I can put this all over 1. So now I have a fraction is equal to a fraction, and I can just cross multiply. That might be easier for us because we cross multiply so often. So if I have sine 23 times X, that's just X times the sine of 23 is equal to, and then 1 times 2,500 is 2,500. Now this sine 23 all has to stay together, and I want to eliminate, or I want to isolate this X. So I'm going to divide by the sine of 23 on both sides. And now I have X is equal to 2,500 divided by the sine of 23. Once you get your variable entirely isolated, that's when you put it into your calculator. So we are going to type 2,500 divided by the sine of 23, and that is going to get us X is equal to 6,398.2617. I'm just checking my work in the calculator real fast. All right, yep, got it. So let's do a similar strategy with the second problem now. I'm trying to find the values of the little b and the little c. I'll draw a line to kind of separate this out. I know this angle right here is 25, and I know this side is 8. I'm trying to figure out b and c. So I first know that 8 is the adjacent side to this 25-degree angle. And let's first find b. B is going to be the opposite side to this 25 degrees. So based off of adjacent and opposite, I know that I have to use tangent. So I'm going to say the tangent of 25 degrees is equal to opposite b over 8. If you want to put this over 1 again and then cross multiply, we can. When we do that, we get 8 times the tangent of 25 degrees is equal to b. Put 8 times the tangent of 25 degrees into your calculator, and we are going to get b is equal to 3.7305. Let's do that for C now. C is on the hypotenuse side. I want to use this 8 in this C because I don't want to use B because it's such a messy number. So I am going to use the adjacent side and the hypotenuse side, which is cosine. I know the cosine of 25 degrees, I'm going to go ahead and put it over 1, is equal to adjacent over hypotenuse, or 8 over C. Let's cross multiply. So C times the cosine of 25 is C cosine 25. And then 1 times 8 is 8. Let me put a dot in between there so we keep those separated, those C's. And now, because this is multiplication, I need to get rid of the cosine of 25, so I'm going to divide by the cosine of 25 on both sides. And this is what I'm putting into my calculator. When I do that, I end up getting C is equal to 8.8270. So let me show you that in the calculator here real quick. I am going to take 8 divided by, and then I've got cosine 25, so I hit the cosine key, and then I put in 25, close my parenthesis, and I have 8.8270. We have one more example and then we'll be done. It says, in 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce its tilt. Its tilt is now at 5 degrees. If someone is 150 feet up in the tower and they drop a quarter off the edge, how far away from the base of the tower will the quarter land? So we need to kind of highlight and focus in on what we need to in this image. We have a triangle drawn here, and what we're saying is the tilt of the Leaning Tower of Pisa is 5 degrees. In other words, this teeny tiny sliver of an angle right there is 5 degrees. Then it says we're 150 feet up from the ground. So this vertical side right here is 150 feet tall. And I have a right angle right there. I'm trying to figure out if somebody were standing right here in the tower and they dropped a quarter from it, how far is this distance, x? So this is very, very similar to these problems up here. I just have to determine what function I need to use and then solve. So I'm going to write SOHCAHTOA again, just so we can see it. Here's my angle 5. And how does x relate to angle 5? Well, that is the opposite side, so I know that much. And then how does 150 relate to angle 5? Well, that is the adjacent side. So if I have the opposite side and the adjacent side of my 3 functions, I have to use tangent because tangent includes opposite and adjacent. So I'm going to set that up first. I'm going to say the tangent of 5 degrees is equal to the opposite side x over the adjacent side 150. Now we want to cross multiply and solve. I'll just keep doing it that way just so you can see it. So I have 150 times the tangent of 5 degrees. I am not multiplying this 150 with this 5. This tangent of 5 is one term. This is one thing altogether, and this 150 can't be put inside of it. Is equal to x. Now I'm going to enter that into my calculator. So I have 150, then I hit the tangent key, and then I am putting in 5, and I get 13.12. So that means it is 13.12 feet away from the base of the tower. All right, that's it for today. If you have questions, please bring them to me in class, and have a good night.